Hello Internet, this is one cursed EVGA card. I've already fixed it. I think I fixed it twice. I'm not sure. Maybe this is the one or maybe it isn't. Either way, I'm gonna read you the everything that I had to do with this to get this card working. So, it powered at first, and then it lost power. It was missing VMon power good. I replaced the power monitoring chip. BIOS was corrupted, so then I reflashed that. It posted, but it continued to lose power, VMon power good. So I ended up replacing that same power monitoring chip several times, rechecked the components. It was so random I couldn't figure this out. Then I just reflowed the core. Nothing changed, and then I found that the 3.3 volt sequence actually outputs 4.3, so got that taken care of. Something along the lines of the diode to the external fan connector. Then I finally got 3.3. Then I had the errors on E1. Ended up reballing or reflowing E1 on both sides. Then it came again. It had a blown LED, something about the LED chip, not sure. Driver MOSFET blown, fuse blown, so replaced that. It worked, but it was stuck at 70% TDP. So I replaced the LED chip, and all lights are red. Voltages are 13.6 volts. It reads 210 megahertz. So I replaced yet another. The same one, but don't know for how many times the power monitoring you see, and it worked. And now he says it's got a red light. So let's figure out what went wrong. Why is this cursed EVGA continues to come back? Let's see if we do have a short on 12 volt or an open line that would explain the red light. So no short, no open line. This one reads open line. Okay, so it definitely have an open line on this guy here. One of the driver MOSFETs blown. Let's take it apart to see what's going on. Yes, this is a warranty card, which means I fixed it before. Something failed within the warranty period, and now I gotta fix it again. At no cost, except that the only cost that the customer pays is the cost of shipping. Alright, so on this card here, I cheated a little bit, trying to save old pads by adding a little bit of thermal paste on that chip. But believe it or not, it actually works really good for whatever reason. I don't know. So, but you apply very little so that it does not ooze all the way around the chip, or at least try not to. Just a small drop. Alright, so let's continue on with disassembly. Okay, what am I doing here? I do not want to power this board. I just want to inject some voltage into here, and we need to figure out what's shorted. Which one? This one? Yeah, this one is short. Okay, so, and the fuse is blown. Perfect. Alright, let's inject some voltage into here. See what's glowing. Hate these EVGA cards. So we're probably going to have some issues with the power monitoring IC after that. Who knows? Hopefully not. But we're injecting something. I'm not seeing anything warming up. It's got to be one of them driver MOSFETs. Which one? What's our amp limit? 4, 5? So we're pulling like 2.5 amps or something. That doesn't look like a dead short driver MOSFET. That sounds like something else. Hard to say. Could be a capacitor. Nothing here. There it is. That guy right there. Let me mark him out. So this guy blew up. I don't know. Let me see if I can show it to you one more time here. Let's find it there. See right there. That guy is getting warm. Okay. Why? I have no idea. What will be the consequences of that? I have no idea. But as you can see here, there's a little bit of flux left all over. So I was working on this chip, all of that was replaced. The PMIC, this guy here, was replaced several times, as well as the one on the back. Yeah, and it was just a big mess. The 3.3 volt sequence was giving us some weird issues. Who cares? Let's replace that driver MOSFET, see if we can bring this card back to life. Alright, so here's a sketchy thing about EVGA cards. Thank you very much. Look at the marking on this chip. So this one ends with a 119. The one next to it, that's not dead. It reads 236. So same model, but it's not the original chip. So this was 19, this was 19, this was 19. All of these are 19s, except this one. But this is not faulty driver MOSFET. So I ended up replacing this MOSFET when in reality, well, not the reality though. This ended up when I replaced this MOSFET originally, this one possibly remained faulty still. and it now finally gave its way. So in the case of EVGA, because they have so many phases on the board that are far more than the controller itself is supporting, what they end up doing is they end up sharing the PWM signal across the two different. They're the same, but they share across the two different phases, and that creates a lot of problems. So they're not using doublers or anything; they're just sharing the PWM across, and we're having issues now. So thanks a lot to EVGA Engineering. And this is why I'm using Black Horse Repairs Flux. See, I didn't even have to bring any alcohol to clean this up. Just wipe it off. It cleans so easy. If I were to put some alcohol in here, it would be perfect. Which I will, but I'm not going to do it right now because the board is still over 100 degrees. So instead, we're going to need to replace that fuse that's blown. This guy here. Yeah, see, I've already replaced that fuse before, so it should be easy. I like this flux. I don't even use that fake Kingbo anymore because of that, because this flux gives me everything and a whole lot better, a whole lot more than the Kingbo ever did. So I'm not doing an ad here. I'm just saying that this is a really good product, and that you should definitely give it a try. He now has his own store online. He's not gonna use that rip-off place that we all know and love called eBay. It's that rips you off like 30% or something. You pay. It's ridiculous. I hate eBay, and the AliExpress is getting terrible recently as well. I thought I would mention it. I've been getting sent cheaper version of the mechanic flux, and what these guys end up doing instead of so I open up a case for refund, for return and refund, and what the AliExpress is now doing, they're giving you automatic partial refund, and they close the case immediately, so you can't even do anything about it. And the good thing is that I paid with PayPal, so I'm able to open a dispute with the PayPal, to which they have not responded. It's always this stupid wick. I'll show you in just a second. So I buy this wick by the bags, because I use it all the time. I got like 3 bags of this stuff. And so I'll show you what the difference is in just a second. And you can see that all of these they're all single layer. That single layer junk never existed until recently. So, and that's what China is doing almost all the time. Once their product gets enough traction on the market, and people become used to it, they buying it in large quantities, it gets popular, everybody's using it, everybody's talking about it, then they switch to garbage, and then you continue on buying this garbage without even knowing that they're ripping you off. And I found out that after buying these, I think I bought 4 bags of this garbage, and then I found out that they were all bad. I just kept them in the drawer just to have supply on the day that I run out. And when I did run out, I started using them, and I was like, what is that? So I opened up a case. Obviously it was already closed. They gave me like a partial refund for maybe 1 bag or so. Yeah, I think they gave me like a 1 bag refund. So I got like 3 bags of this garbage that's practically useless. It's very, very thin, and I couldn't wrap my head around why is it soaking up? Why is it becoming useless so quick? When I started using it, I was like, and then I looked around, tried the older batch, and that's where I found out that the mechanic is now a piece of trash. And the exact same thing applies to these small preheating stations. So I got the old one. The original one, it was really good. The old original ones, they come with this small heating plate. All of the newer ones, they come with a larger plate. I'll show you. The newer ones, they come with a plate like this. It's larger, and the controls are garbage. Everything is garbage. It's slow to react. It's very slow to adjust the temperatures. And it's buggy. So yeah, this is like the only thing that actually works. And every time I ask a seller, I want to see what you're selling. Show me the actual item, and then their photo. Obviously, the photo shows this, but on their list, but when you actually getting it delivered, it's gonna be like that, and it's gonna be garbage. So the one way to tell whether or not you're gonna be buying a garbage or a good mechanic IX5 preheating station is it's gonna have yellow LEDs, not blue. If you see blue, it's a new PCB, a slightly different design inside. A lot of problems with it. As a matter of fact, I'm having problems with this particular one. The board itself is still old design, but it came from a more recently developed version of the same thing with a bigger plate. And so while the circuit is still the same, it was still part of the newer version. So some things were cut down or something, and I'm constantly having issues with power. It refuses to stay on if it's like really cold. So I have to like warm it up with hot air before something actually clicks inside and it starts to work. But the original and the old original controllers that came with that, I ended up using them to control this heating element. So it was all the same board, same controls, everything. So I just ended up printing that, and using it to control this heating element instead. So, but it is what it is. That's what China does, and they will never stop. Thanks, China. Now let's go back to the positive and have a look at that driver MOSFET. We're still a little bit warm, but like I said, I have not wiped this with alcohol yet, and it looks like it doesn't need to be wiped. I mean, this whole area here, where I just wiped it with a dry Q-tip, looks cleaner than anywhere else on the board. See in here and there. I mean, it's incredible the way this flux works. It's just so easy to clean. I don't even know why would I put any alcohol in here. So this is like a non-clean, non-wipe, nothing. You don't need to do nothing. Just use it, wipe it. Look at this. I didn't have to do it. And it's not even looking any better than it was before I used alcohol on it. See, it's not making a whole lot of difference. It was already clean. That's why I like this flux. I don't think Northridge Fix can match that. And I don't care. Now, while the GPU is cooling down, I probably mentioned this multimeter here that I got. It's a decent multimeter. I think it's gonna run you down about $100. So it's not cheap by any means, but it does have a reasonably functional oscilloscope and a signal generator. So I don't really like the oscilloscope part of this because it's all, while the controls are somewhat intuitive with the touchscreen and all that, it's still too small, and it's not really fast enough. Doesn't have a whole lot of mega sampling rate, to really see a clear picture of the signal. Because sometimes you can have like minor issues that you will never be able to see on this thing, but you're gonna need it. Like even the cheapest desktop size scope will show you, whereas this one will not. So the other thing is, I constantly have to have it powered, so it's always plugged into the charger, because the battery here isn't. I mean, it'll probably last a day, no problem. But then, so I just ended up leaving it plugged in, and so when I turn off the whole station, obviously it's not charging anymore. And what's interesting is that it'll stay on overnight. So I wake up in the morning or noon, whatever, and it's still on, and it'd probably be about 10-20% still alive. So that way I don't have to worry about it, losing charge and whatnot. Just leave it plugged in all the time. I'm sure that's going to deteriorate the battery faster, but I don't care. But as far as everything else goes, it's highly customizable. I really like the way it works. I am almost permanently switching to it, so I've been working with this for probably about a week. I kind of like it, though I wish it was a little bit maybe bigger, a little bit more bigger battery in there would be nice. And the power button wasn't protruding, so I ended up just dropping a little drop of the epoxy here to make that button stand out so it's easier. And yeah, it's not bad. I like the graph here though at the bottom. It kind of helps you to compare things, such as what you will see me compare is I will be comparing these 12 volt rails one to another, and they're supposed to be charging the same, so you'll see how the capacitors charge. So if we like measure here, and you see that the graph is kind of slowly changing, it's the way it looks. So if I switch to this one, it'll probably be about the same or different. And so what you're seeing right now is that this one and this one, they're charging identical, but this one does not. So that means there's probably a capacitor here, or maybe it will still a little bit warm on this end. Hard to say. So it's probably something like a capacitor, most likely, is not up to the specs and whatnot. So that's one of the ways this particular feature rather, can kind of point you to a potential problem with the circuit. So we're just gonna go ahead and short that to ground. So we can discharge the circuit, and then we're gonna check. So we've now reset, so it'll beep in diode mode as well. So while you're measuring the voltage drop, you're also seeing the resistance, and you can hear a beep, so that's very nice. So let's reset, just by you hold the graph and it just resets the whole thing, and then we can start measuring the resistance. So let's measure the first one here, and that's what we're getting here. That's how it charges. Let's measure the second one, and it's nearly the same. And the third one, see how long that takes to charge. So that to me is a sign that something is slightly reading low for whatever reason. Yeah, that's why this graph is very useful. And it's also reading like 300 some ohms for whatever reason. So, but we're gonna figure out what's going on here. It could be one of them capacitors that's bad. I don't know. So we're not gonna power this thing right away. We're just gonna start injecting some voltage in here and see how it behaves. See if we can spot any kind of problems. Looks like this chip is starting to glow a little bit. That's that one of them power monitoring ICs that I said can sometimes cause issues when 12 volt short. See here, it's kind of glowing, but that not necessarily make it a problem. It's supposed to glow because it's feeding 12 volt. So let's see if we can. We're gonna limit the amperage to like 1 amp or something. So let's give this thing 12 volt and 1 amp. See what's gonna happen. Yeah, so that chip is definitely glowing, as you can see here. As I suspected. We're gonna have a problem with this chip. So we're gonna have to replace this. And on the back, I don't remember, was it this one? Yeah, so on the back we're looking good. Yeah, just that one guy that's warming up. So let's go and replace this. That's probably what's driving the resistance low. So let's replace that real quick and see if that normalizes the way that the this whole 12 volt rail charges. And we're going to be looking at it with that multimeter, which is good. So with what I said earlier about the Chinese flipping good product with garbage, eventually, if you want this multimeter, you want a good one, get it now. Don't wait. Just go on the AliExpress or Amazon or wherever you want to buy this guy, and just buy it right now. Don't wait, because the longer you wait, the higher the chances of them to start selling you some kind of garbage that's not even remotely close to what I have here. So remember, this is what we see before, the kind of signal that we were getting. Now unfortunately I cannot scroll back. It would be a nice feature to have if we could just scroll back, a couple of minutes backwards, just give us some kind of a history, but we don't. So the only thing that we have is we can reset. So thank you for that feature, to the very least. So let's see how different this is. We're going to compare the good one. So there's a good one. This one's a good one. See, you've got a steady rise. Now let's check this one here. And it's the exact same thing. See, I got 3 exact same rates of charge, which means we probably got a fix. So 318 ohms on the 5 volt. That's normal for this card. And this multimeter will read very different values on circuit like 1.8, for example, because different multimeters, they use different voltages to measure resistances. So this one is gonna measure different. Usually it's like a 1.8K or something. In this case, we're only getting 770 ohms, so it just depends on the multimeter. But funny enough, if we flip the probes, what are we getting? I don't even know what are we getting for when we flip the probes. I can't even measure it when we flip the probes. And that's the beauty of a semiconductor. Let's see. 1.8K, 2K, 2.2K. So if we're measuring the kilo ohm range, we're getting this. But if we're getting in a beeper mode, we're getting 772 ohms, which is weird. Why is it reading this? I don't know. Let's see. Do we have like a manual range? Yes, we have a manual range. We can set that to 600 ohms, and we're getting, let's go higher, 6K. Yeah, there we go. That's more like it. Regardless, so at the very least we have option to limit the range that we're interested in. So that's great. I don't know what the offline and online means, to be honest. Yeah, we're still reading. No, now we're reading 1.2K. So that's more likely. That's probably some old ways of measuring. I'm not sure. Okay. The EV blog guy was mentioning something about the old ways and the new ways of measuring. I'm not exactly sure what he meant by that. I'm guessing it's this option here. Don't know exactly what that means. I'm not that tech savvy anyway. But regardless, I think we have a fix. Let's go ahead and power this thing on. We still might have issues with the secondary power monitoring IC that's directly on the other side of the board. Right there, the exact same chip. That might have problems also. They usually do with blown driver MOSFETs. So it's almost never know. Let's see what happens when we power the board. Let's have a look. Stupid app constantly needs to be reopened. I probably want to use the oscilloscope to check the phase, the way it looks. And according to the thermal camera, everything is looking absolutely gorgeous, as you can see here. All of the phases are looking very nice, very evenly distributed, but it won't hurt to check. The ones that are hot are memory. That's perfectly normal. Memory is always working harder. So let's see, I think we had beautiful, beautiful, beautiful. Yep. So all of these phases look identical. So I think we might have a fix. Not exactly sure why it failed. It looks like it's the driver MOSFET that's one of the original ones, and that failed. Why? I have no idea. Probably has something to do with the EVGA's design, most likely, how they like to share PWMs across driver MOSFETs. So great job, EVGA. And but regardless, we're doing this for free, even though it's not my fault that it's completely different, it's completely separate driver MOSFET failed. And warranty is warranty, you know, what can you do? And some people complaining about not wanting to ship it for warranty, but that rarely happens. So I'm not going to be changing any of my terms just because of one guy. Alright, I think we got a post. Yep, there we go. So the card posted. We're going to wait for Windows to install the drivers and make sure that there are no issues in terms of power monitoring, and then assemble it, run some tests, and hopefully everything goes well. Alright, drivers loaded. Let's have a look at the GPU-Z, and we're probably going to run some kind of a light load on the lowest settings. Alright, so what do we want to see? We want to see voltages that are reported correctly. 12 volt, 12 volt, 12 volt, 12 volt. We do not want to see, we can disregard this voltage here. I want to see normal power, lowest TDP, and then we're going to run something. I want to see the clocks jumping to the max and then dipping down as the requirement decreases, as it were demand. And there we go. Temperature's going up. We're not reading anything weird, so I think we're good. We got lucky this time with just one driver MOSFET and one power monitoring IC. So I'm going to go ahead and put this thing together. I'll run some more tests, and hopefully this is it. Hopefully this video was entertaining, maybe educating, who knows? Let me know either way. Goodbye. Alright, we're back. As you can see here, we're only doing 70% TDP. That's a problem. Why that is, I do not know. I can try switching the BIOS. The voltage is reading okay. The only issue I'm having is that it says that the pin number 3 is pulling significantly lower amperage or the power compared to... Oh, pin number 1 is not pulling anything. See right there, that's why. Okay, so we need to go and revisit. It's most likely the power monitoring IC on the back that's causing this issue. So let's go and take care of that. Probably replace it, see what's going on, because the voltages are reading okay. So if the voltages are reading okay, then that means at the very least the resistors that are connected to the power monitoring IC are okay. So it's probably the chip itself that's died. That's why I don't do live repairs. I just can't. I cannot have a video that's not structured. I cannot have chaos in my videos. I need to have structured content so that you can follow, so that my head doesn't spin, and but it is what it is. Let's see. So at the very least, we know what is wrong with this cord. Hopefully, I mean, theoretically, that's the only thing that needs to be replaced. We can even do this by without even taking this thing apart. So probably do this right here, right now, and without taking it completely apart. That's perfectly fine. That chip isn't that big anyway, and it's already has leaded solder under there since I've had it replaced before. So all we need to do is just simply remove it. It will come out at a lower temperatures compared to what it normally would be. And let's go and prepare a replacement. It's going to be the exact same chip. Obviously, it was listed as brand new in China, but it is not brand new. You cannot buy brand new parts in China. Remember that when you go shopping for parts in China. Everything that they listed as new, even when it's packaged like new, it's all used, removed somewhere, thrown into the ultrasonic, cleaned up, and sold to you as brand new. And sometimes they have enough guts to not only sell you used part, but at a price 2 or 3 times higher compared to you buying it from Mauser, for example, or DGK. So whatever, it depends on the chip. Some kind of a rare laptop chip could be sold for a ridiculous high price simply because you didn't look at the Mauser and see what they have in stock, which is often what happens to me. I kind of assume that the Mauser doesn't have anything. So, because a lot of times when I want something from Mauser, I want it for the purposes of getting it quick. If, you know, like a laptop or something. But for GPU repairs, a lot of times I just have these parts available. And if there's something weird, then I go to China. And they like to just charge you way more than it's worth. But it is what it is. So let's go and replace this thing real quick. See if anything changes. Now I really hope this is it, because sometimes it might actually be the first chip that I replaced on the other end, or on the other side of the board, because I don't know which one of them is faulty. So it could be that the one that's on the back that failed after the dryer musset blew up, or it could be that the replacement one was faulty straight from China. You just never know. And these power monitoring ICs often come with issues like that. So, but who knows? Sometimes it's always a gamble, you know. Unless you're buying them brand new from Mauser or DGK that can actually guarantee that you're buying it brand new. You know, probably be a smart thing to do anyway. But it is what it is. Matter of fact, I do have about a stack of them, like 20 or so, from Mauser, I believe. But I still need to do something with the old ones, so I don't want to throw them away, you know. So I'll just keep on replacing them at my own cost, I suppose. And if I find them not working, I'll just continue on juggling them around until I, you know, waste enough time to conclude that I have half of them that are dead. Who cares? It's my time. I can do whatever I want with it. My own boss. All right, let's go ahead, open up GPU-Z. I probably should have noticed the stats of very low watt from earlier, but I didn't see it for whatever reason. I don't know. Let's launch GPU-Z. I missed it. That's all I'm trying to say. So we have 6 watt, 6 watt, and the exact same 1 watt. So it's the power. Yeah, it's still not rising. It's not rising. The power is not rising on the 8 pin number 1. See, 1 watt. Something is still not working right. The voltages are okay, but the 1 watt is still stuck. So I think that the chip at the front was either faulty or I don't even know anymore. I can try different BIOS. I doubt the BIOS will do anything. I can also try see, the thing is with the EVGA, they're very picky when it comes to power monitoring. Sometimes they can give you false readings just because your drivers like corrupted or something, or got mixed up with the other drivers. So I'm gonna go ahead and try a different PC and confirm before I start taking this thing apart and replacing and soldering the chip that I removed from the back to the front of the board, suspecting that the front chip was bad. I don't know, it's just a lot of waste of time here. So I'm gonna go ahead and try another PC and see what I find out. Yep, this thing just does not want to work. So on the other PC, it's doing the exact same thing. So I don't know. I guess I'm gonna have to replace front power monitoring chip and see what that does. So what we're gonna do now is I'm gonna take that chip that I stole from the back of the board, solder it here, assuming that it's working, since it produced no change. Since the replacement of it produced no change, so I am kind of assuming here. And if that changes nothing, then the problem is with the circuit somewhere. Then we're gonna start digging around, trying to figure out what's going on. It could be half dead fuse, but if the fuse was half dead, it would drop voltage reading, but the voltage reading did not drop. So I don't know. The reading of voltages was seemingly okay. Hard to say. Probably wanna. All right. Let's see if we can solder this chip somehow. That looks good, I think. Clean it up and try again. That's all I can do. Hopefully I will not have to revisit this repair here on the left. Don't remember exactly what's going on in here, but I think the trace was burned. Yeah, there was a lot that went wrong with this card originally. I was actually surprised that I was able to get it to work with so many faults all at once in so many different places. I don't know what people do to these things. Like overclocking maybe? No idea. There, as you can see, I was measuring that circuit in a voltage drop mode. You can see here that the reading before I powered the board, when I replaced the chip on the back, you can see that every 12 volt rail measured identical. So you can use diode mode to measure that. It'll also give you a graph that you can compare. Alright, so let's go and reset this. Alright, here's the card. Let's make sure that we don't have any short. So that, and that look the same. Yeah, they all look the same. They're climbing the same way. Alright, 5 volts still good. 1.8 PEX 3.3. Okay. Should we... Okay, let's power this on in a controlled manner, because if this chip is soldered upside down, which can happen, we're gonna have a short, but only after we power it on. So let's see, thermal camera. That's why you want to power this on in a controlled manner every time you replace these chips. Looks good. Okay, let's go into Windows and see if the reading has now changed. Alright, here we are. So we're reading pin number 3, 12 volt, 12 watt, 12 volt, 9 watt, 12 volt, 12 watt. Alright, that's it. I think we've done it. So it looks like the chip that we had replaced originally was faulty. So now you can see that we're pulling more or less the same wattage across all 3 of the 12 volt PCIe cables. So that's what we want to see. So hopefully that will be it. Hopefully I can finally lay this one to rest. And again, thank you for your time watching this video, for all your likes and comments, from which I do take lessons once in a while. Some useful information would pop out, such as, you know, flux or this or that, or somebody, like I said, somebody suggested that multimeter, and I looked around and was like, huh, and I did not regret the day I bought it. So again, thank you. And don't forget to like, subscribe, and if you're interested in this kind of stuff. And hopefully I'll see you later on my channel. Goodbye again. And by the way, if anybody cares, I did try the EVBlog's multimeter, and it was slow, and it was overpriced, and it was a piece of trash. So I said it. Go cry to your mommy.